Okay, in 8.1, this is video number 3. We'll talk about converting equations between rectangular and polar form. All right, converting equations between rectangular and polar form. Polar form equations only contain r and theta. It's very important that you know that. Possibly sometimes you'll have the sine and or cosine. And then rectangular form should only contain x and y. So make sure when you have a polar form, your equation should only have r and theta, and then in rectangular form, you should only have x and y. All right, remember these facts, use substitution and algebra manipulation to change the equations. So here, this is everything that you guys would need. All right, so here's r, where it equals the square root of x squared plus y squared. The line's a little off there, but it is the square root of x squared plus y squared. Also, r squared equals x squared plus y squared. Those two are tied together. Tangent theta equals y over x equals r cosine theta, y equals r sine theta. Now would be a good time to pause and write all of these equations down so that you have them in your notes for your test. Okay, so let's move on with this. These are just the guidelines that you saw in video number 2. There they are again. Just make sure you're sticking to these guidelines. The first example, we have 3x squared plus 3y squared equals 27. What we're trying to do is we're trying to convert these rectangular. How would I know that both of these examples are rectangular? They both have x and y. So we're going to change these both to rectangular, both from rectangular to polar form. All right. Simplify first if you can. Okay, so if we look at that first example, I noticed that I could take out a 3 out of everything. So if I divide by 3, I have x squared. So dividing everything by 3, I have x squared plus y squared equals 9. Well, take a look. One of our equations over here involves x squared and y squared. So we'll apply that. Since x squared plus y squared equals r squared, I can take x squared and y squared and replace it with r squared, and that equals 9. And if I simplify that by taking the square root plus or minus of both sides, r would equal plus or minus 3. And now I'm in polar form. How about the second example? In the second example, notice I have y equals negative x. Well, if you take a look at that one and I divide both sides by x, I now have y over x equals negative 1. Well, y over x, that actually is also one of our rules. Tangent theta equals y over x. So now I can replace y over x with tangent theta. So tangent theta equals negative 1. Well, where is the tangent? At what angle is the tangent equal to negative 1? Well, if I were to draw that real quick, your past chapters, we do know that it's here, right in the middle, and it's here, right in the middle. Those are both negative in the second and fourth quadrants. Our tangent would be negative 1 there, and our tangent is negative 1 there. That's a terrible drawing. I'll try and do it one more time. X and y axis, negative, negative tangent, both there. Well, at what angles are those? That will be when theta is equal to 3 pi over 4, and when theta is equal to 7 pi over 4. Both answers are required, and both answers are good. Let's keep it moving. X equals 7. It might look like there's nothing that you can do, but actually there is, because if you look over, here's some rules. X actually equals r cosine theta. So I'll replace the x with r cosine theta. R cosine theta equals 7. And then what can I do? I can divide both sides by the cosine of theta. And then remember your rules, don't have fractions. That's gone. R will equal, with no fractions, we know that 7 over the cosine of theta is the same thing as 7 secant of theta. Final answer. That one little rectangular problem went to polar form. Same thing for the second example. I'm sure you could do it. Y is equal to r sine theta. And so instead of putting r, I can put r sine of theta equals -3. Then what am I going to do? Divide both sides by the sine of theta. And then r equals -3. We don't like fractions, but it's the same thing as the cosecant of theta. So r equals -3 cosecant theta. Now we're in polar form, so let's convert from polar to rectangular. R equals 12. Okay, well, you do have a couple of things. Look over at the table over here. Remember, these should all be written down for you in your notes before you take your tests. But R equals 12. Well, if we use that, that's fine. We can use, I'm just actually going to use this one, R squared equals X squared plus Y squared. So that means that R squared is 12 squared equals X squared plus Y squared. Well, that's just 144. So my final answer would be X squared plus Y squared equals 144. Later, we're going to look at that. That's the equation for a circle with a radius of 12. So in polar form, radius of 12 gives you a circle with a radius of 12. And this is the old rectangular form. The old rectangular form for a, right here, the old rectangular form of a circle, x squared plus y squared equals 144. Radius would be 12. Second example, theta equals pi over 4. Well, if we look at that, we can use the tangent of theta. Tangent of theta equals y over x. Well, if the tangent of theta equals y over x, we already know that theta is pi over 4 from this example. So tangent of pi over 4 equals y over x. Again, I'm just using this. I know theta. They gave me theta to be pi over 4. Well, what is the tangent of pi over 4 is the question. Well, you guys all know that. If you draw it, pi over 4 is here. The tangent should be 1. So I have 1. Tangent pi over 4 is 1 equals y over x. Then I'll just solve for y by multiplying both sides by x. And y equals x. If you look at the polar form, pi over 4, when we get to this, it's a straight line at pi over 4 also extends through. And then y over x also is that same line, y over x. Rectangular form, polar form can give you the same graph. Okay, r sine theta equals 3. You might see that one as the easiest problem ever because r sine theta equals 3 is just right here. So if I replace the r sine of theta, I can replace that with y equals 3. Just that easy. And the last example here, this is kind of a tricky one. I did want to show it to you guys, but what you do is multiply both sides by 1 plus the sine of theta on both sides. Multiply by 1 plus the sine of theta. And this kind of watch as I work. All right, so now I have r times 1 plus the sine of theta. This side equals, this and this would cancel, equals 1. Now what I can do is I can distribute the r. So I now have r plus r sine of theta equals 1. Well, r sine theta, that's right here again, r sine theta is just y. Now I have r plus y equals 1. If I subtract r on both sides, I have y equals 1 minus r. And then think about what r is. R is up here. It's the square root of x squared plus y squared. So now I have y equals 1 minus the square root of x squared plus y squared. And now you may be thinking at this point, I'm done with all my thetas. I'm done with all my r's. You can actually get this one to look a little bit nicer, but I've usually given kids credit if you've gotten this far. I'll take it a little bit further and kind of show you where else I went. I subtracted 1 on both sides. So I subtracted this 1, subtracted 1. And now I have y minus 1 equals negative square root of x squared plus y squared. Then I can square both sides to get rid of that square root. I can square this side, and that would leave me with, I'm going to get rid of that square root to just leave me with x squared plus y squared, and the negative also gets squared, so I should put that in parentheses there. So I'm left with x squared plus y squared. If I FOIL this out right here, the y minus 1 squared, I would end up with y squared minus 2y plus 1. Take a look what happens. The y squares are now gone. I mean, this is just a little bit extra. You don't really have to even know how to do this far. Getting to the point where you got rid of r and theta when we were here was fine. I'm just showing you a little bit of extra steps. Now I'm left with x squared equals negative 2y plus 1. At that point, I think I'm just going to stop. You can kind of get the idea of how far you can go. I mean, you could solve that last one for y by subtracting 1, then dividing by negative 2 to finally end up with y equals x squared minus 1 divided by negative 2. So any of these answers would work. I honestly would take this answer right here. Once you're done with theta and r, I'm okay. Okay. Well, that's all of 8.1. If you have any questions, let us know.